Okay guys, now I'll be practicing the second formula or second case, as I uh, told you earlier that we are having 4 cases of student t distribution, and I have practiced the first case in front of you. uh, Now I'll be presenting the second case in practice, then how this test would be done on this video. So I'll be going towards my question, and that would be uh, this is our second case, and I'll be selecting question number 18.19. So I'll be solving 18.19b part. How do we test the hypothesis for this one? First of all, read the question. Two random samples taken independently from the normal population with an identical variance yielding the following results. So here we are given 2 samples, and with the related detail. In sample 1 we are having number of observation as 12. Mean of these 12 sample is 10, and the variance of this sample is 1200. And the sample 2 carries the number of observation 18. The mean of the sample 2 is 25, and the variance of the sample 2 is 900. So guys, this is the sample variance, and the question is, test the hypothesis that the true difference between the population mean is 10. That is that the mu2 minus mu1 is equal to 10. That is actually the null hypothesis against the alternative that the mu2 minus mu1 is more than 10. So point to be noted there, that the alternative is having not the unequal sign, it is having a more than 10 a sign, which means that this test would be a one-sided test on the positive area on the right side of the diagram, and that test would be conducted at the 5% degree of significance. So guys, this is the question, and now I'm going to practice this question. How do we do the hypothesis testing on that? So for that I'm going again to my so this is actually the main theme and main steps for the hypothesis testing. I have mentioned that I'm solving this problem number 18.19, and in the first step I have already done the hypothesis statement. Null hypothesis is saying that the mu2 minus mu1 is equal to 10. It means that the difference between the means of the two populations is 10, while the alternative hypothesis that the difference is more than 10, the difference between the means is greater than 10. And at the step 2 we are having a 5% level of significance. And guys, we know that the case is of it is not the case of equal variance. Let me correct this one, because in the question we are not given anywhere that the population variances are same or identical. Sorry, it is given to us. Yes, it is given to us, the population with an identical variance. So this is identical variance case. So this is the identical variance case, and we are having this kind of technique for that. So test statistic on the third stage we are having like that: x2 bar minus x1 bar minus mu2 minus mu1 divided by pooled standard deviation, multiplied by the square root of n1 inverse plus n2 inverse. And here we need to calculate the pool standard variance or standard deviation. So the pool standard variance formula is given here. So we have to first calculate the pool standard variance, and then getting the standard deviation from it, then we will be following this formula. The fourth step is to get the critical region, and now we are having n1 as 12 and 2 as 18. So 12 plus 18, 30 minus 2, 28. So T alpha 0.05 we will be seeing in the row of 28. We are not dividing this alpha by 2 because this is not a two-tailed test, it is a one-tailed test. So that's why complete alpha would be given to the critical region. So T alpha critical region would be area of the T which is greater than plus T alpha with n1 plus n2 minus 2 degree of freedom. So T 0.05 is our level of significance, and the degree of freedom is 28. So this is T alpha on the plus side with 28 degree of freedom. So therefore we have to consult the table. What would be the tabulated value of the T on the one-sided test? So here we are having 0.05 is not being divided by 2 because this is the half of it, but we will be taking the full of 5% and on the against the 28 degree of freedom. So 28 degree of freedom is somewhere this is our 28 degree freedom. So this is 0.05 level of significance and this is 28 degree of freedom. So I am getting this 1.701. This is our tabulated value or critical value of our symmetry. So 1.701, that should be in mind. So I am here taking this value 1.701. So this is our value actually, the tabulated value. I am keeping it bold. So 1.701 is our critical value. Now we'll be calculating our T normal value of the difference, that is T ratio. And but we have I've told you that first of all we have to calculate the standard deviation of the pool sample. So guys, I have already done it for you. You have to just focus on it and see the procedure. So here I have calculated the pooled variance. You can see that from this formula, n1 minus 1, that is 12 minus 1 into s1 square, that is 1200, plus n2 minus 1, 18 minus 1 into s2 square, that is 900, divided by n1 and 2 minus 2. This is being replaced on the denominator. By solving this formula, we are having we get the variance of 1017.86. 101.86 is our variance of this pooled data. But here the variance is not being used, it is there the standard deviation being used. So this is a square form, this is not a square form. We have to take the square root of this value to get this SP. So I have already done it for you as well. So just I am putting the values. Here you can see I have put the values over there. It should be clearly to see that x2 minus x1 is 25 minus 10 minus mu2 minus mu1, that is being 10, and divided by SP is 31.90. 31.90 is the square root of this variance, and after that 1 over n1, 1 over 12 plus 1 over n2, that is 1 over 18. So by solving this I'll be getting the answer. If I solve it, so this is actually our the normal difference about this mean. So guys, here we are having the T value of the table, the distribution, and the estimated T value as a 0.421. Now just we have to make the conclusion, and it's very simple to understand that the 0.421 is not more than 1.701. It means that this 0.421 is lying at the area of less than this limit. So obviously we cannot reject null hypothesis. So all this we have to write it here. First of all I will select the proper language, and then since the calculated value lies in acceptance region, that is for 0.421 is less than 1.701, therefore we cannot reject null hypothesis. It means the difference between the two population is said to be the 10, because we are accepting as not an not state that the difference between the means of the two population is 10. We have accepted that. So thus how we can practice such kind of hypothesis testing. And guys, please do it at your home, and make yourself very clear about it. And if you have any kind of question or query, you can ask me on my WhatsApp, and you can mail me as well. And inshallah we will see you in the